Hello students, welcome to Aptdemy's live class. I hope you are going through Aptdemy's course material available in Aptdemy's portal. Now, based on your feedback, today I will be discussing a problem from geometrical optics. Let us see what the problem is. So, the problem is basically related to Snell's law and refraction of light. So, let us see the problem statement. A ray of light traveling in air is incident at grazing angle. Incident angle is almost 90 degrees on a long rectangular slab of transparent media of thickness T equal to 1 meter. The point of incidence is the origin 0, 0. That point is A. The medium has a variable index of refraction N1 given by this expression, where K is 1 meter to the power minus 1.5. The refractive index of air is unit. Okay. Obtain the relation between the slope of the trajectory of the ray at a point Bxy in the medium and the incident angle at that point. B. Obtain an equation for the trajectory Yx of the ray in the medium. C. Determine the coordinates x1, y1 of the point P where the ray intersects the upper surface of the slab air boundary and indicate the path of the ray subsequently. So this is a slab bounded by these two yellow lines, you can say, and below the slab air medium is there, above the slab air is there, and the thickness of the slab is 1 meter, and this is origin of the coordinate system. This is x direction, this is y direction, and the refractive index of the media is a function of y. It is continuously changing as you move up. Okay. Now, and there is a ray of light striking the point A, and the angle of incidence, and as it has been said, the ray is incident at grazing angle. That means the angle of incidence I is almost 90 degree here. I is almost 90 degree. Okay. Now, I is almost 90 degree. Now, just let us recall Snell's law. You know if there are two media, one is N1 and this is N2. This is medium 1, this is medium 2. And refractive index of medium 1 is N1, refractive index of medium 2 is N2. If a ray of light strikes at the interface of these two media, and if the angle of incidence, this is the angle of incidence, that means at the point of incidence, if you draw a normal to the interface, then the angle the incident ray makes with the normal, that is called angle of incidence, and the direction of ray changes. Had there been no interface, then the ray would have gone like this. But because of another presence of another media above medium 1, the light ray bends, and this phenomena we call refraction of light, and this angle is called angle of refraction, and this theta 1 and theta 2 can be determined using Snell's law. If theta 1 is known, the angle of refraction theta 2 can be determined using Snell's law. N1 sin theta 1 equal to N2 sin theta 2. And this is famous Snell's law, which guides us to determine the angle of refraction in the medium 2. And see, from applying Snell's law, you can readily show that if a light goes from denser to rarer medium, then at the if this ray of light after striking the interface, it goes away from the normal and moves like this. That means in this case theta 1, if this is theta 1 and this is theta 2. Obviously, theta 2 is greater than theta 1. Whereas in the reverse case, that means when the ray of light strikes from rare to denser medium, this is the angle of incidence. This is the angle of incidence, and after refraction, the refracted ray comes nearer to the normal. So this is theta 2, and theta 2 is less than theta 1. Okay, so had there been no interface, no difference in media, the ray would have gone like this. But because of this presence of medium 2 above medium 1, the refracted ray comes closer to the normal. So these all we know from our basic background on refraction. Okay, now this problem, what is happening? Below the slab, there is a constant air medium, and as soon as the ray strikes, it suffers refraction, but the refractive index continuously is changing, and therefore the direction of ray is also continuously changing. Now what happens in this case? Let us see. So if I remove the entire thing, what happens? See, here as the ray proceeds upside, it continuously suffers refraction because the refractive index is continuously changing. Now see, let us see what happens really over there. So let me remove this thing also. So this is the ray, this is the angle of incidence, and it comes nearer to the normal. And since the media is continuously changing, so it is again coming nearer to the normal. As a result, between the boundaries of the slab, if the ray enters like this, the ray direction continuously changes, and finally it strikes the upper interface between the medium and the air. And again, finally, when it emerges like this. Okay. Now, any point in between the boundary layers, boundary interfaces, boundaries of the media and air, what happens? Let us see. So, says this is one point bxy. It is said that obtain a relation between the slope of the trajectory of the ray at a point bxy. So let B is a point in the media whose coordinate is xy. This is origin. A is the origin. This is x-axis. This is y-axis. And original ray actually has fallen at the interface at this point A. And the angle of incidence is this much. This is almost 90. Now, as it strikes the point A, it bends towards the normal. So instead of going like this, it has gone like this. And finally, it is passing through the point B. And then finally, it strikes the upper boundary. Okay, now what is happening? Since the ray continuously suffers refraction, the path inside the slab is not straight like this. It is continuously bending, and finally it is striking the upper boundary. Now, this is the, if you draw a parallel line, through BXY parallel to x-axis. So this is a interface between upper layer and lower layer. And see, since n is like this, n y is square root of k y to the power 3 by 2 plus 1. And since k's value is 1, so I can write ny is 1 plus y to the power 3 by 2. And for positive values of y, ny is always greater than 1. So the media continuously, the refractive index of the media is increasing as the ray moves in the upward direction. Initially, the refractive index below the slab was unity, and as the ray enters, it sees a refractive index whose refractive index is more than unity, and therefore the path of the light ray would be from rarer to denser medium. And as a result, the light ray will continuously bend towards the normal. So the path, instead of a straight path like this, the path will be bent towards the normal and it will be like this. Now what happens? At any moment xy, at any point xy, you can think that there are parallel layers of optical media whose index of refraction is continuously changing. So from this point, let the trajectory be like this, which is not a straight line obviously, and this is the point A, which is 0, 0. The ray moves like this. Now at the point B, whose coordinate is xy, at the point B, if you draw a tangent, then the direction of tangent indicates the direction of incident ray at the point B. And see, at the point B, you draw a line parallel to x-axis, and at the point B, just below this horizontal line, there is a media, and just above the bounded parallel line, there is another media, because refractive index is continuously changing. And since y value is just below this layer, this horizontal layer, which is parallel to x-axis, y value is less, and here the layer just above this horizontal line is more. Therefore, refractive index will be more, and there will be a bending of light direction at this point also. And the angle of incidence can be safely taken as the direction from, can be calculated from the direction of tangent. So this is the tangent line, and if let the tangent makes an angle I with the normal. Okay, so this angle is I, this angle. So what happens if this angle, this particular angle is theta, which is the slope of the tangent, and then theta and I is the angle of incidence of the light at the point B. I and theta divided by I plus theta is obviously pi by 2. I think this point is clear. The ray is continuously bending, and this becomes the trajectory of the light ray. This becomes this yellow line. Let me draw it one second. And let me draw a tangent, not like this. Sorry. One second. Let me draw. This concept is very, very important. So, this is the trajectory of the ray, and at this point B, whose coordinate is xy, remember this is x-axis and this direction is y axis. Now what I do, I draw a tangent at the point B, tangent to the trajectory at the point B. So if, and we draw a normal like this at the point B. Layers are like this. So this horizontal line, you call it H1, H2, horizontal line. We have drawn a horizontal line H1, H2 through B, which is parallel to x-axis. So above the horizontal line H1, H2, refractive index is more, and below more than the refractive index of the media, just below the layer H1, H2. And as a result, the ray of light continuously bends toward the normal. Okay. So at the point B, I have drawn a tangent, and what the tangent makes, let the tangent makes an angle theta with horizontal axis at this point, and this angle, the tangent makes angle I with the normal. Okay, this angle is I. Okay, now obviously I plus theta is pi by 2. Therefore, angle of incidence I can write pi by 2 minus theta. All right. Now see what this theta indicates. Theta indicates if y is a function of x, that is y represents the profile of the path, trajectory of the light ray, then dy dx is nothing but the gradient of the trajectory at the point xy. So dy dx is gradient of the trajectory at the point xy. So dy dx is nothing but tan of theta. Okay, so dy dx is the gradient of the tangent of the trajectory at the point xy, and which is nothing but, from diagram it is very clear, the slope of the tangent, this angle is theta, so dy dx is tan theta. Now how theta and angle of incidence I are related at this point? Theta is equal to pi by 2 minus I, and therefore I can safely write dy dx equal to tan pi by 2 minus I. So this is how much it is cot I. So dy dx equal to cot I. This relation or equation gives the slope of the trajectory of the ray at a point bxy in the medium and the incident angle at that point. So this is the desired relation. So again I am explaining the light ray from vacuum or air. It is striking at the point A, whose coordinate is 0, 0 at the bottom of the slab. And as the refractive index of the slab is continuously changing in the upward direction, and it is denser than the air medium, therefore the beam of light is continuously bending towards the normal, and the beam of light or ray of light takes a trajectory like this. At any point B, xy, if I draw a horizontal line h1, h2, then the media just above the layer h1, h2 will be more than the media, refractive index of the media just below the layer h1, h2. And as a result, always the ray gets bent towards the normal. Now, if I draw a tangent to the trajectory of the profile at the point dxy, then the that direction of tangent actually indicates the direction of incident ray, and this incident ray makes an angle I with the normal. So this angle, this much angle is angle of incidence, and whatever angle the tangent makes with x-axis, that angle if you call theta, then tan theta is nothing but dy dx. But theta and I are related by this equation, so we can take theta equal to pi by 2 minus I, and therefore dy dx equal to tan pi by 2 minus I cot I. So this is the first relation. Obtain a relation between the slope of the trajectory of the ray at a point bxy in the media and the incident angle at that point. Next part, so this much is okay. 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 So let us proceed to the next part of the problem. So we have already found that dy dx, sorry, dy dx equal to cot I. Now, second part, obtain the equation for the trajectory yx of the ray in the medium. So we have seen that the path bends like this. So this curve is represented as yx. Okay, y as a function of x. Now, what is this expression of y, or how y depends on x? That expression you have to find out. Now, Snell's law I can write for this type of situation. N sin I is equal to constant. Okay, so for different layers, whatever n is also function of y, so n sin I is a constant. Wherever you apply, because if there are multiple, if this is n1 and this is n2, so this is I1 and this is I2. So N1 sin I1 is equal to N2 sin I2. So wherever you take the angle of incidence in this path, and even below the slab or above the slab, n multiplied by sin I is constant. This is Snell's law's generalization for this case. So if I take d n sin I, this is becoming 0. Okay, so it is dn sin I plus n cos I di equal to 0. So, or we can write sin I dn is equal to minus n cos I di. So I can write dn by n is equal to minus cot I di. So little calculus, I get this result. Okay, so let us see what we can do with this. So dn by n equal to minus cot I di. So dn by n is equal to minus cot I di. I can write this as d sin I by cos I. So the technique of integration I have applied. D sin I is cos I di, and here there will be sin I. So this side, right hand side becomes cos I di divided by sin I. So it is minus cot I di. So from this I can readily write this. So if I integrate both sides, so what happens? Log n with base e. Ln n I can write. Ln n is logarithm n with base e is minus log sin I plus some constant c1. Okay, So if I bring this negative ln sin I in the right hand side, left hand side, then it becomes ln n sin I is equal to C1. Okay, so n sin I, ln n sin I equal to C1. Now that is basically sin n sin I is equal to constant. Now you see sin I, what is the value of the constant? What is the value of this constant? Let me try to find out. So n sin I equal to some constant C1 say. Now this formula is applicable for all points in this geometry. So when n is 1, I is 90 degree almost. This is the given condition because this situation, this angle is 90 degree. The ray is incident at the bottom of the slab at raising angle almost. So when n equal to 1 and at this point value of n is 1 unity. So I can write 1 sin 90 equal to C. Sin 90 is 1, so I can take C equal to 1. So I simply write n sin I is equal to 1. This step is actually not necessary. So n sin, this step we can discard. This is not necessary. Just without integration also we can say n sin I equal to constant. The value of constant I can write as unity because just below the slab n sin I equal to constant. If I apply n equal to 1 and I equal to almost 90 degree, then value of constant comes out to be unity. Okay. Now let us see what happens. So far what we have done, so far we have seen that this relation we have already obtained dy dx equal to cot of I and n sin I is equal to unity for this particular problem. So sin I is 1 by n and cos I is root over 1 minus 1 by n square. So it is how much? It is square root of n square minus 1 divided by n. So cot I from this expression I can write root over n square minus 1. Okay, because this divided by cos I divided by sin I gives cot I equal to root over n square minus 1. But cot I is actually dy dx. Therefore, dy dx is root over n square minus 1. But n is given as square root of 1 plus y to the power 3 by 2 because we have already seen with y to the power 3 by 2 k's value is unity that we have already seen. So n square minus 1 is how much? N square minus 1 is y to the power 3 by 2. Okay. Okay. So it is y to the power 3 by 2. See carefully. This is square root of 1 plus y to the power 3 by 2. So n square is, I can write n square is 1 plus y to the power 3 by 2. So n square minus 1 is y to the power 3 by 2. And that whole to the power half. Square root of n square minus 1. So dy dx is y to the power 3 by 4. So from there, what I can write? So dy into y to the power minus 3 by 4 is equal to dx. So if we integrate both sides now, so what happens? Y to the power minus 3 by 4 plus 1 divided by minus 3 by 4 plus 1 is equal to x plus some constant, say k1. So what is this? Now let me remove this part. For calculation, let me take this space. So it is y to the power 1 by 4 and denominator there is another 1 by 4. So 4 y to the power 1 by 4 is equal to x plus k1. But for the given problem, we know at x equal to 0, y equal to 0. We are trying to find the equation of the trajectory. And for the trajectory where x equal to 0, y equal to 0, because it is striking, the ray of light is striking the bottom layer of the slab at the point 0, 0. So at x equal to 0, y equal to 0, if you plug in, then I get 0 equal to 0 plus k1. So this implies k1 is 0. So the expression becomes x equal to 4 y to the power 1 by 4. Okay. So that means 4 y to the power 0.25. So x equal to 4 y to the power 0.25 is the equation of the trajectory of the light beam inside the medium. Okay, so light beam, instead of moving along straight line, it will bend. It will be continuously bending, and the ray of light will move along this trajectory, whose equation is given by x equal to 4 y to the power 0.25. Okay, now what next? It is, they have asked at which point the ray of light will exit the slab. Okay, now at the point of exit, the y coordinate of the trajectory is definitely y equal to 1 meter, because the thickness of the slab is given as 1 meter. So at the exit point, so at the exit point, y equal to 1 meter, you can say 1 m. So when y is 1, then x value is simply 4, only 4, and unit is 4 meter. Therefore, the coordinate of exit point is nothing but, if I call this point E, it is 4, 1. Okay. And unit is meter, 4 meter, 1 meter. Now next is indicate the path of the ray subsequently. Now as soon as it comes out of the slab, then again Snell's law is satisfied. N sin I is equal to unity, because we have seen that the value of constant is unity, and since n is 1 outside the slab, so sin I becomes unity, so I again becomes 90 degree. That means it was incident, the ray striked the bottom surface at grazing angle, and it leaves at grazing angle. And actually the angle of incidence is equal to the angle of refraction at this point also. Okay, so it is parallel to the ray, the emergent ray is parallel to the incident ray. Okay, so the emergent ray becomes parallel to the incident ray, and this is the path of the ray, you can say. And if the reversibility also is applied, that means if the light strikes the upper boundary like this, then it emerges like this. Okay, so the ray will emerge parallel to the incident ray. So this problem is a simple application of Snell's law, but in variable mean. Because you know, if parallel slab, if there is a slab like this, then if a ray of light strikes like this, then we know from our refraction knowledge that the ray moves like this, and again it comes like this, parallel to the incident ray. These two rays are parallel. So here also it happens like this, but instead of a straight path inside the slab, here the slab's refractive index is uniform. Here the ray is a curved path. The path of light takes in the media is not a straight path, it moves along a curved path. So inside the slab, it is a curved path. So this path's equation we have found x equal to 4y to the power 0.25, and where it emerges the slab, that point also you could calculate, and you could also establish that the path will be coming, the ray will be coming out at an angle of refraction which is also 90 degrees almost. That means it will be coming out of the beam with at a grazing angle. Okay. So this was all about the problem. I think you have enjoyed the problem. It's a very interesting problem where the application of Snell's law in variable media we have covered. Okay. So if you understand the basic principle, then it is okay. And you see the guiding principle is n sine I is equal to constant. So it is the generalized version of Snell's law, you can say. And n sine I equal to constant. Okay. Okay, I hope this lecture was useful to you. Thank you. Keep on sending us feedbacks. Thank you very much.